The scalar product of two vectors. National 5 Essential Skills. Finding the magnitude of a vector. The scalar product is denoted by A dot B and is sometimes called the dot product. It can be calculated using the formula A dot B equals the magnitude of A multiplied by the magnitude of B multiplied by cos theta, where theta is the angle between the two vectors A and B when they are placed tail to tail. From the diagrams, the first one we have vectors placed tail to tail with the angle in between, therefore we could find the dot product. The second diagram we will not be able to find the dot product because the vectors are not placed tail to tail. Key steps for finding the scalar product: calculate the magnitude of each vector, check vectors are tail to tail before deciding on the angle in which to use, place the magnitudes and angle into the formulae, and finally evaluate your answer. A practical example of scalar product would be energy absorption from solar panels. One vector would be the solar rays, the other is where the solar panel is pointing. We could see that the energy absorption could be calculated by the overlap in direction multiplied by the strength in rays multiplied by the size of panel. Or in other words, the energy is equal to cos theta multiplied by the magnitude of A multiplied by the magnitude of B. If you hold your panel sideways to the sun, therefore at a 90-degree angle, no rays will hit and therefore no energy will be generated. The scalar product would be 0. The reason the scalar product would be 0 because cos of 90 is equal to 0. Example 1. Find the value of A dot B. Here we can see we have two vectors A and B, and they have magnitudes 7 and 3 respectively. The angle in between is 60 degrees. First thing we'll do is we'll write out the scalar product formulae. Inserting the values will give 7 multiplied by 3 multiplied by cos 60 degrees. Cos of 60 degrees is equal to a half, so 7 multiplied by 3 multiplied by a half will give a final answer of 21 over 2. Example 2. The vector u has magnitude k and v is twice as long as vector u. The angle between u and v is 30 degrees as shown below. Find an expression for u dot v in terms of k. Now from the diagram we can see that vector v and u are not tail to tail. However, we can move vector u, and if we shift it, we then realise that the angle between vector u and v when tail to tail is 130 degrees. Inserting the values into our formulae is written in terms of the question. U dot v is equal to the magnitude of u multiplied by the magnitude of v multiplied by cos theta. U has a magnitude of k, so it's k multiplied by, v had a magnitude twice as long as u, therefore 2k multiplied by cos of 150 degrees. Simplified, k multiplied by 2k will give 2k squared, and cos of 150 degrees is negative root 3 over 2. We can cancel the 2 beside the k squared and 2 in the bottom of the fraction to give a final answer of negative root 3k squared. Now try these examples on your own. Please pause the video. The answers for A dot B is equal to 10, and for B, U dot B is equal to negative 35 root 2 all over 2. If you would like some extra practice, please turn to page 259, exercise 13O, question 1 and 2. Today we have learned about the scalar product of two vectors. The key steps are calculating the magnitude of each vector, checking the vectors are tail to tail, and if not, moving them to find the angle between them. Place magnitudes and angle into the formulae, and finally evaluating your answer.